Welcome pre-cal students to class today on Friday the 14th. Hope you guys are doing well. Hope you're ready to learn some math today. Here we go. Still got a little bit of the cold thing, so I know my voice is going to be annoying, but I think we can handle that. Here we go. There will be a quiz tomorrow. I will email that to you. I might even email it to you today. I have it already. I just have to send that email off. So there will be a quiz on Saturday, and it will be due on Tuesday. Completely done. All questions asked. Number two, your tests are due Saturday. Now, Matthew and Kayla, both of you guys have contacted me due to weather, thus conflicting with soccer and work. Both of you are turning it in a little later, so I understand that. But sorry, each of you know when your tests are due, so make sure you stay on top of that. Number three, integrity sheets. Make sure you stay on top of those. And Monday is President's Day. There will not be a video for you to watch on Monday, okay? And I can hear you guys cheering all the way to my house. We'll be finishing lesson 1.2 today and also going over what will be on your quiz. Let's go ahead and go over what will be on your quiz tomorrow. Now, you know in these videos, I go fast and you have to pause it a lot. So I'm going to go ahead and start talking to you. If you'll turn your books to page 70, all that I have done is I have gone through your homework assignments from Monday, Tuesday, Wednesday, Thursday. Oh, did you catch that? Monday, Tuesday, Wednesday, Thursday. Usually the material on Friday, if I give you homework, and I am giving you homework, usually that material is on your quiz. I am not putting today's material on your quiz, taking a little easy on you. So your homework from Monday, Tuesday, Wednesday, and Thursday is what's on the quiz. So all that I did is I turned to your Monday assignment, page 70, and I picked problems out of the sections. Then I turned to your Tuesday assignment, which was also lesson 1.1, and I picked problems out of those sections. Then Wednesday was lesson 1.2, and I went ahead. Oh, I'm sorry. I apologize to you. Sorry about that. Monday was a test, wasn't it? I'm sorry about that. So Tuesday, Wednesday, Thursday is what the quiz will cover. So Tuesday was part of lesson 1.1, Wednesday was part of lesson 1.1, and Thursday was part of lesson 1.2. So you have the homework assignments from these 3 days. Look over the homework. There'll be nothing on the quiz that wasn't on your homework from these 3 days. All right? Easy enough. That was simple. I'm not trying to be rushed or anything, but there really isn't a whole lot more I can say. So study before you look at your quiz and you take it. And let's go ahead and continue on. Today in your notes, you will be... Okay, I'm back. Sorry about that, guys. Today in your notes, you will be learning how to find domain and range. However, we will be doing this given two different scenarios. Scenario number one, I give you a function. That's the harder of the two scenarios. Number two, I give you a graph. That's the easier scenario. Okay? Now, by the way, when I give you a function, all that you're going to do today is just find the domain. When I give you a graph, you're going to find the domain and the range both. Okay? So you know what? Let's jump into it. Let's get after it and let's get this done. Let's conquer the more difficult topic first. Here's your heading, finding domain and range of functions, and the date today is 2/14/14. 2/14/14. All right, here we go. Find the domain of this function right here. Now, first of all, when I ask you to find the domain, what I'm saying is this. You're finding what, you might want to write this down, x is allowed to be. Now sometimes x will be allowed to be everything. Sometimes there will be limits. Every problem will be different, okay? So when I ask you to find the domain of this function, I'm asking you to find what x is allowed to be. Now when you look at this, if I were to start putting numbers in for x, 1, 2, 3, -1, -2, -3, 0, 4, 5, 6, let's say I was graphing it and I started putting numbers in for x, you realize I could not put a 3 in for x, because if I put a 3 in for x, I would get 3 minus 3, and 3 minus 3 is 0. And you're never allowed to have a 0 in the denominator of a fraction. So do you see how when you're given a rational expression or a fractional expression as a function, the denominator can never equal 0? So when you're given expressions like these, and there are different types, you simply take the denominator, you set it equal to 0, and you solve. Why, Mr. Earhart? That shows you what x cannot be. It shows you what x cannot be. You know that this whole expression right down here cannot equal 0. So we're going to set it equal to 0, bring the 3 over and make it a positive 3. And x equals 3. So you just found what x cannot be. Now, let me encourage you to get into the habit of drawing a number line. Once you find out what x can or cannot be, and I'm telling you right now, this is so helpful, so you better listen to my advice on this, guys. I'm telling you, this is so helpful for you to get a visual of this. X cannot be 3, so I'm going to put a hole right there. And then x can be everything else going this way, and x can be everything else going this way. Now, I want you, this is not your answer. You're just getting a visual of it. Now, using this visual, I want you to learn to write your answer 3 different ways. First of all, you can use words. You could say the set of x such that x, I'm going to word that a little differently. I'm going to do something different. You can write it with words, all real numbers, so that x does not equal 3. You could also use an inequality. Look at this. X is less than 3, so you could say x is less than 3. Also, just put a comma, x is greater than 3. Notice it's not equal to 3. You don't put an equal sign there. And then the last method is called interval notation. Interval notation. This is a little difficult and you're not used to it, so please pay attention. You use intervals, parentheses, and brackets. Let me show you. Notice how to the left it goes on and on for infinity. So for this area right here to the left of 3, I would put a parentheses, infinity. And actually, I would put negative infinity because that's the direction going to the left, comma, and then a 3, and then a parentheses. Now, if 3 would have been colored in and 3 would have been allowed, then you would put a bracket right here. Bracket means including this number. Parentheses means not including. Whenever you use an infinity, you always use a parentheses, never a bracket. Okay? So, what I'm saying here is the domain runs from negative infinity all the way to 3, not including 3, and you can put a comma if you want, and then it starts at 3 again. Notice I put a parentheses because it does not include 3. There's a hole right there at the graph. And it goes to the right, so that would be positive infinity. And there. This is using words, this is using inequalities, and this is using interval notation. You must be able to do all 3. You must. All right, let's take a look at the next one. Now, when it comes to radicals, we just talked about fractions back here and how a denominator can never equal what? 0. It can never equal 0. Well, a radical can never have a negative number when it's a square root or a 4th root or 6th root. But so I cannot take, now watch this, I cannot take the square root of negative 6 or the square root of negative 10 or the square root of negative 1 or the square root of negative 20. I cannot do that, okay? You cannot take the square root of a negative number. So there are some things that x cannot be. So here's what you do. You take the inside of the radical, and again, we're going to find out what x can't be. So we're going to say (3 minus x less than 0). We're finding out what x can't be. Now watch, this makes sense. Watch. We're saying this whole side here, this whole expression right here, less than 0. Anything less than 0 is a negative number. So we're finding out what x is so that it's less than 0. So first of all, bring the positive 3 over. When you bring the positive 3 over, it becomes a negative 3. Next, even though you can't see it, there's a negative 1 here. So we divide both signs by negative 1. However, do you remember in Algebra 2, we taught you this, when you divide by a negative number, you have to turn the arrow. Anytime you divide or multiply an entire inequality by a negative number, you must turn the arrow, always. And what are we dividing by? A negative number, a negative 1. So you must turn the arrow. These cancel, leaving you with x. Negative 3 over negative 1 is a positive 3. So you just found out what x cannot be. I didn't say what x can be. You just found out what x can't be. Got it? So here's 0, 1, 2, 3. Here's 3. There's what x cannot be. All right? I should color this in. Because what x cannot be is greater than 3. Mr. Earhart, how do you know that x can be 3? Well, put a 3 in right here, guys. What's 3 minus 3? 0. Can you take the square root of 0? Sure you can. Whoever said you couldn't? The square root of 0 is 0. Certainly. So, this is what x, actually I better not color it in, it'd be confusing. This is what x cannot be right here. So if that's what x can't be, then that means everything else, sorry about that, that means everything over here is what x can be, including 3. So, how do we write this with, first of all, words? You would say, x is less than or equal to 3. That's what x has to be. By the way, try it and see. Put a 2 in. 3 minus 2 is 1. Put a 1 in. 3 minus 1 is 2. Put a 0 in. 3 minus 0 is 3. Now, put a 4 in and watch what happens. 3 minus 4 is negative 1. No good. Put a 5 in. 3 minus 5 is negative 2. No good. Okay? So x is less than or equal to 3. Let me get a drink here. X is less than or equal to 3. Or you can write it with inequalities. X is less than or equal to 3. Or, now watch, you can use interval notation. So we start to the left. It runs from negative infinity all the way to 3. And it includes 3, so we put a bracket. And that's it. That's it. You must know how to write all of this. If you got to back this up and watch these again, do so. Okay? All right. Okay, now this one's going to be a little trickier. Okay? But again, we have a denominator, a fraction. And so 2 problems ago we learned we take our denominator and we set it equal to 0 to see what x cannot be. So I'm going to do the same thing. I'm going to take my denominator and set it equal to 0 to find out what x cannot be. Now, we should know how to solve these. We're going to factor it. I will not go over factoring. We should know how to do this by now. What 2 numbers multiplied together give you negative 3, when added together give you 2. Would be a positive 3 and a negative 1. There. Now you take each group and set each group equal to 0. X plus 3 equals 0. X minus 1 equals 0. X equals negative 3. X equals 1. So these, I'm going to put slashes. These are the 2 numbers that x cannot be. Got it? X cannot be those 2 numbers. So what I've taught you to do is get a picture of it with the number line. So here's your number line right here. 0, over here is negative 3, and here's 1. Now, x cannot equal this, and x cannot equal this. So x can equal everything over here, everything in between negative 3 and 1, and everything over here. So we have 3 groups. Group number 1, group number 2, and group number 3. So first of all, let's write that with words. X would be what? All real numbers, right? All real numbers, except that x cannot equal what? Negative 3 and 1. It's easy. All real numbers such that x does not equal negative 3 and 1. Now let's go ahead and use inequalities. X is less than negative 3. That's this group right here. X is in between negative 3 and 1, so we use a conjunction like this. That makes sense. X is greater than negative 3 and x is less than 1. I'll put commas here. and then x is greater than 1. X is greater than 1. Look that over. For group number 1, x is less than 3. For group number 2, it's in between these two numbers, so x is greater than negative 3, x is less than 1. And then for my group to the right, x is greater than 1. And now interval notation. How would I write this group over here with interval notation? Well, it'd be negative infinity all the way up to what number? Negative 3, not including negative 3, so parentheses. And then group number 2 would be from negative 3 to 1, not including negative 1, not including negative 1, and not including negative 3 or 1, either one. And then the last group over here, well, it starts at 1, not inclusive, so we put a parentheses, and it goes to the right, so we say positive infinity. There we go. One more, then we'll look at the graphs, okay? All right, now this one here is really simple. Come on, guys. Is there anything you can't put in for x? Guys, there is no number that you can't take to the third power. Sorry for using the double negative, but there is no number that you can't take to the third power. You can put any number in for x. Negative, positive, fractions, decimals, zeros, anything. There is nothing that you can't put in to an absolute value. Nothing, guys. I mean, nothing. You can put anything in for x. So this one's really easy. And this will happen a lot in your homework tonight. All real numbers. That's it. That's the domain. When it's all real numbers, I'm not going to worry about having you write it with inequalities. But interval notation would be negative infinity to positive infinity. That's all real numbers. Okay, guys? That was pretty simple. Now let's get into the graphs. I'm going to keep moving, but I would encourage you to turn to page 82 in your books, all right? Because I want you to have a picture of what we're doing. And now we're going to find the domain and range. Now, domain is what x is allowed to be. Range, then, is what y is allowed to be. So, we're going to go ahead and we're going to find the domain and range by looking at a graph. Now, let's start with the domain. Domain, you have to look at what this thing is doing going left to right. So here's the graph right here. Do you see the graph? And it looks like it's doing nothing over here. It looks like it starts at negative 4, the graph, and it goes to the right. That's what it looks like to me. Can you all see that okay? So when you're dealing with domain, you're looking at left to right behavior. And so it's doing nothing to the left, but you can see it's going to the right. So that tells me that the domain is everything from negative 4 all the way to the right. So think of a number line again. Number lines help. Here's 0. Here's negative 4. It looks like x is everything from here and going this way. So first of all, how would I write that with words? I would say x is, I'm not going to write it out, you can listen to it. X is greater than or equal to negative 4. You would use words. Inequalities, you would say x is greater than or equal to negative 4. Now with interval notation, you're starting at negative 4, going from left to right, and notice it is inclusive, so you put a bracket, and it's going on and on, so you would put infinity. There, that's interval notation. That's pretty good for the domain. Now let's take a look at the range. The range is what y is allowed to be. So now we're going to look at the behavior going up and down. Well, I see the graph starting here. It doesn't go down. It goes up. And as it goes more and more to the right like this, it's continuing slowly and slowly to get higher and higher. So it looks like to me, if you're going to look at what this thing is doing going up and down, it looks like it starts here at 0 on the y-axis. 0, Mr. Earhart? Well, yeah, look. I mean, it's starting right here on the x-axis. Where is that at on the y-axis? I mean, it's not down here at negative 1. It's not down here at negative 2. It's at 0. And it's getting higher. It's getting higher. The graph is going up, up, up. It's not going down, down, down. So I would say on a number line, I have negative 4, and it's getting higher or greater. So it'd be the exact same thing. So your range would be like, you would use the letter y, and you would say y is greater than or equal to negative 4. or you could use an inequality, y is greater than or equal to -4, or you could use interval notation. You're starting at -4, it's inclusive, so put a bracket, and then you're going to the right, so it would be infinity. There you go. Not too difficult. Now again, I'm going a little fast, but you can always slow me down, but you can't speed me up. So I'm definitely going fast, but you guys will be fine as long if you need to back it up and watch it again. Really study this, okay? All right, now let's find the domain of this graph. Notice, look carefully. Notice as it's coming down right here, it's still getting wider little by little. So I don't care how gradual it is, as it goes down, 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 it's never going to quit going to the left. And as it goes up, it's still going to the right little by little. So I see the graph is going this way. It's defined. You have a graph all the way here, here, here. It's going this way. I see nothing that x is not allowed to be. I mean nothing at all. Okay? I mean it's going to continue going this way. It's going to continue going this way. And there's no breaks in the graph like a hole right here or something like that. So the domain is very simple. The domain is all real numbers, and when it's all real numbers we don't use inequalities, and so we would say x. You need to put x so I know it's the domain. X is all real numbers. Interval notation is -infinity to infinity. Well, the range is going to be the same thing. Look guys, now for the range you're looking at up and down behavior. Well, they really should have put arrows on the end. I'm disappointed they didn't. But notice how this graph continues going down, down, down. It's never going to stop. It continues going up, up, up. It's never going to stop. And all in between here, there's no holes or anything. Well, then again, same thing. Y is, I'm using ditto marks, y is all real numbers. And when it's all real numbers, we don't worry about inequalities. It would be -infinity to +infinity. There we go. Guys, you just got to look at the graph, look at the left-right behavior, look at the up-down behavior, and then you'll be good, okay? All right, let's take a look at this graph here. Now, be careful on this and watch carefully. Let's start with the domain. Notice how the graph, and if you don't know on a test or quiz, I'll tell you, it is continuing on. But it's not continuing to the right. See this blue line? This is called an asymptote. It's an imaginary line the graph is not going to cross. Okay, the graph will never hit that. So we see the graph continues this way to the left, on and on. But we see as it gets close to 2, that number 2 right there, it goes down, but it never hits 2. And same thing over here. We see the graph goes more and more to the right, but notice as it goes up, it gets closer and closer to this blue line, but it's never going to hit it. And so the graph is never going to be defined here at 2. Never. Never, never, never. Never does this graph hit 2 on the x-axis. Look at it. It's to the left of -2, and the graph is to the right of -2, but it never hits 2. So on a number line, I would have this. I would say the graph goes this way, and the graph goes this way. So, all real numbers, x is all real numbers with words here, so that x does not equal 2. Or inequalities, x is less than 2, comma, x is greater than 2. No equal signs like this. No equal signs. Interval notation, well, going from left to right, we're coming from -infinity all the way to 2, use a parentheses, and then going left to right, we start with 2, and we go to infinity. There we go. Words, inequalities, interval notation. All right, let me get a drink here real quick. And now let's talk about your range, okay? Your range. Now your range deals with your up and down movement. Now watch this, guys. Look, as the graph definitely goes up, 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 and never stops. But look, as it comes down, it never hits 0. It never hits the x-axis. It never hits this red line, which is at 0. And yes, the graph goes down, 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 right here. That's fine. But look, when it comes up, it never hits this red line. It never hits 0. Never. So this graph goes all the way up, it comes down, but it doesn't hit 0. I'm saying 0 because look guys, we're dealing with the up-down movement. So we're looking at So we're looking at this right here. All right, hold on one second. So we're looking at the y-axis, and it's never going to hit 0 right there. All right. So the graph goes down, down. When it comes up right here, it never hits 0. So if I put that on a number line, it looks like this. I've got everything greater than 0, everything less than 0. So my answer would be x is all real. I'm not going to write it out, but you can listen. With words, it would be x is all real numbers such that x does not equal 0. Inequalities would be x is less than 0, comma, x is greater than 0. And then for interval notation for this region here, notice we start at the left and work to the right. So the left is going to be negative infinity, comma, going all the way to 0. Notice it's not colored in, so we put a parenthesis. And then we say starting at 0 going to the right, 0 to infinity. Let me get a drink here. So there's the range for that graph. I personally find these a lot easier than the function ones because you just look at the graph and figure it out. Okay, now this one here, be very careful, okay? Let's talk about left to right movement. As it goes up, it is continuing slowly but surely to get wider and wider to the left. And it comes down. There's no holes in the graph. Everything's good. As it goes up to the right, it does continue to go more and more to the right. By the way, on a test or quiz, if you can't tell if it's going more to the left or right, I will tell you, yes, it is. I will let you know that. So, the range is going all the way to the left, all the way to the right. There's no, the domain, sorry. There's no break in the graph. So the domain is going to simply be x such that x is all real numbers. All right. We don't do inequalities for these. We just do interval notation. And whenever it's all real numbers, it's negative infinity to infinity. Piece of cake. Now let's talk about the range. Because look, guys, does it continue going up, up, up? You bet it does. But does it continue going down, down, down? No. It stops right here. It never goes below what number? -4. Never. It never goes below -4. So, on a test or quiz, well, Mr. Earl, I don't know if it's equal to 4. I would tell you, in this case it is. It hits 4. It hits 4, but it never goes below 4. So let's get that on the number line. It looks like to me your range is always going to stay above -4, above -4, including -4. It includes -4. So it would be this. Putting it on a number line, your range equals -4, and it goes above or higher than -4. So, with that in mind, now I'm going to use words, inequalities, and interval notation. For the words, I would say x is all real numbers. Oh, sorry, that's incorrect. I apologize. I would say x is greater than, I'm not going to write it all out, but x is greater than or equal to -4. Using inequalities, I would say x is greater than or equal to -4. Using interval notation, you start to the left and go to the right. I would use a bracket because it does include -4. Okay? So -4 going to the right would be positive infinity. So there's interval notation. You always use a parenthesis, not a bracket, when dealing with infinity or negative infinity. Okay? There you go. Now it's about, you can look right here on the computer screen, you can see it's about 9:19 in the morning. I'll do the homework a little later today. But I hope you guys are not so dependent upon the homework video that you can't do your homework. I mean, you should, yes, there's 20 problems, but you're going to see half of them are like the graphs. You just look at it, write things down, and the other half are really pretty easy functions, to be honest with you. A lot of the answers are just all real numbers, all real numbers. But anyways, the homework assignment will be posted here probably later today, maybe the next hour or two. But you can do the homework. You don't have to have the video to do the homework. You can go ahead and get started. You can check the odds in the back of the book and then check the evens with the video. Okay? So call or email if you have any questions. And hope you guys have a good day today. So that's far.